Let us start it again. Now, what I've just told you, you have to use one test piece or sample workpiece, which we can use over which we can make this indent and test the size of the indent to make your problem, to do your work. But you cannot use the original work because original machine member, because it's creating an indent over the surface of your workpiece may not be made, kept it usable. So to remain usable, you have to use a portion of that said machine members, which is manufactured in the same method, but in the standard shape as per the size of as per your machine application of machine, and you have to check all these tests over it. Now, question you have to set, what you have to do here, you have to select your indenter, your load, question is how you have to select. There is a specific process of selection given by the concerned machine manufacturers, given by, say, Brinell, Hardness machine, testing machine, maker. What is that? Let us see. Now, I'm just repeating the same thing which I've told you, I think. What is Brinell hardness testing machine? Is a production type hardness testing machine designed. It is designed for measuring the Brinell hardness of steel and other metals, whether flat, round, or round, circular, or irregular in shape. It is simple in design, easy to operate, and very sensitive and accurate. It gives you very accurate, provided you can check, measure this indent accurately with eye means of your microscope. And this is a production type hardness testing, means it is used in the production shop to make a rapid and quick hardness testing of your produced items. Now, what we have in this machine, it is a fully enclosed steel fabricated body, and it has a mechanism inside it, protected from dust and extraneous elements. It consists of a J frame. It just looks like a J-shaped frame, J-shaped J shape. It has main lever. It has main lever, a hanger, elevating screw, and loading and unloading and damper mechanism. Means machine should have a certain structure of its own to carry every of these items. And here the items concerned are the main lever, which is housed inside the machine, which is applying the load to through the indenter to the workpiece, hanger over which the loads are hung, elevating screw, over which the load are released after the work is complete, and the loading and unloading mechanism inside the machine, and a damper mechanism. Damper means it is carrying the load when it is not in use. Not in use, or it is, or when it's not in applied state. Now, load is applied on the specimen through a board holder. It is affected through a lever through mechanism. So load is applied on the specimen here. Is a ball holder is there through a ball holder which holds a ball, and this load is applied through a lever mechanism. There are 5 detachable weights. There are 5 detachable weights. One is all are equivalent to 500 kg, and 2 are equivalent to 250 kgs. Now, these loads, detachable weights, are not equal to 500 or half tons of weight, but it creates, by means of a lever mechanism, an equivalent weight of 500 kg to the concerned indenter, to the point of the indenter. But they themselves is not 500 kg of 500 kg weight, or they themselves is not as high as 3,000 kg weight, which is we are trying to apply on certain work pieces as per our application. So proper operating lever is also produced by loading and unloading, and this lever mechanism is used for applying these comparatively small loads to such a huge magnitude to the concerned indenter. Load range I've just told you, it is sized between 500 kg to 3000 kg. Like this, it is 500 kg to 3000 kg. Its chest height can be 250, means 25 centimeter only. And depth of the throat means there is a hole inside the platform over which this load is kept. That is called the throat. It has a hole inside it to house the platform perfectly. This depth of the throat is around 15 centimeter depth. The gross weight of the machine is 220 kg, and the height is 99, almost 1 meter of length. The base size is 459, almost 500 to 255 millimeter. Now, how we are selecting the loads? How to select the loads? The process of selection of the load is given here. Ball indenter is given as 10 millimeter. These are the indenters we are supposed to select from it. And we have only 2 sides here, 10 as well as 5. We don't have this 2.5 millimeter ball at our places. And the load you can apply through it is equal to 3000 for steel and iron, and 750 for 750 with 5 millimeter indenter, and for 3000 with 10 millimeter indenter you can apply for steel and iron. For case of brass, we can apply 10,000 kg on as well as 250 kg. We cannot, our machine cannot permit the loading of less than 500 kg. So we have to use for brass only 1000 kg with 10 millimeter ball indenter. And aluminum testing we can make 500 kg, and that too is with a ball indenter of 10 millimeter. And soft wearing material we can't measure here, but still if you like, we can apply 250 kg multiplied given to the 10 millimeter indenter. So first we have to know what is the material. Here either steel or brass or aluminum is given, and the maximum load we can apply with it is equal to 3000 or 10 millimeter, or 10 only 1000 for 10 millimeter indenter, and 500 for 10 millimeter indenter, and 250 for 10 millimeter indenter. So here, from the selection of your load of the raw material of checking, you can select the magnitude of the external applied load and the size of the indenter. So this is the process of checking the indenter. It has few standard accessories, and like this, which is shown here, and it has weight. Just I've told you, it is weight hanger. It has a weight hanger, which means a method over which an item or machine member over which a load can be hung over the work or stand work. After screwing the bottom load hooked on the hanger V, this assembly is equivalent to 500 kg load on the body indenter, out of which remaining 6 So there are remaining 6 weights, 2 are 250 kg, and 4 are equivalent to 500 kg load. So we have 500 kg of 4 into 500 kg means 2000 kg equivalent load, and 250 and 6 weight, 2, and there is another 500 kg of the load of the hanger means 2500 kg, and that is also 250 kg weight, which total as a whole we have 4 500 kg load, 1 500 kg hanger, 250 kg load. So this is the weight which are periodically, as per the requirement, we are applying through indenter to the workpiece to create the indent. Now, how to do it? What is the method of test here? For Brinell hardness test, what we do here, first of all, the surface of the specimen on which the impression should be made should be flat, smooth, clean, and dry, and free from oxide, scale, and pits. So that should be perfectly produced, perfectly clean. It should be smooth means polished properly, and should be clean. It should be dry. It should be wet by means of some certain means and certain liquids, and free from any sort of oxide, scales, and pits. So workpiece should be specimen, surface of the specimen, workpiece specimen should be free of oxide, scales, clean, and free of oxide, scales, and specimen. Well, the ball holder steel balls of 10 to 5 millimeter diameters, and one of the steel weights weigh 3,000, 250 to 750, 250, and 250 kg are thus selected in the test. The hardness steel ball is impressed on the surface upon the load. Its ball remains there for 15 seconds, and the diameter of the inspection surface is measured by a microscope accuracy 0.001 millimeter. For ferrous plate, the load range becomes 30 multiplied by d into d. It is the diameter of the indent, diameter of the ball. Dia of the ball indenter. It is if you have 10 millimeter diameter ball, it will become 3,000 load kg. Non-ferrous metal, the load should be 50 into d into d and 255 into d into d. So here you also apply, you can apply the load and do the checking here necessary. The Brinell load is obtained from the equation. DHN load on the Brinell ball area of the indentation 2 into p into pi into d. 2 into p divided by pi into d multiplied by d minus capital D minus small d. When Brinell hardness number by DHN, the Vietnam number here, and the P is the load applied in kg, and which is given here. D is the diameter of the indent 8 kg, and small d is the diameter of the advertising machine. Now, how to operate the machine? For carrying out the test, the following steps is supposed to be adopted very clearly. How? Keep the operating lever in the horizontal position and rightwards. Place the specimen on the testing base. Turn the nut in clockwise direction so that the specimen will push the indenter, and lift the indenter operating lever from horizontal position upward, after which it starts to operate automatically. So we have an operating lever here. We are lifted upwards to actuate the system. Next, thus the indenter is actuated and pressurize the workpiece considerable amount. Thus, when the lever becomes standstill, we have to apply the load accordingly. Bring the lever back to the horizontal position. 7. Turn back the nut and remove the specimen, and carry the same procedure for further specimens. There are standard state blocks applied along with the machine that can be verified the accuracy of the tester. In case of deviation from the dedicated below, the certain limits are given, and then the changes are, say, the notice while changing, charging against 10 millimeter ball diameter and 5 millimeter ball diameter. Then charging changes the ball. Let us see this picture in a bit more detail. Just a second. Now we are sharing the Brinell Hardness chart. What is shown in the chart? First of all, the ball diameter is given. The indented diameter, or what is the ball diameter is given here. Ball diameter should be 5 millimeter. And what we have got, the load applied is given as 750 millimeter, 750 kg, or it can apply load up to 250 millimeter kg. And with this, we got the impression of 1.26 above the ball. So if we have 750 kg load and impression we have made is 1.26 millimeter, so we have Brinell hardness of the constant test is equal to 592. Similarly, here is also given, that is another 750 millimeter, or say 250 millimeter kg weight. And if we calculate the, with this, if we calculate the measured impression is 1.83 millimeter, then the Brinell hardness should be 91.7. Here, if we say, if we apply another 750 kg here, right here, then we have the impression of size 2.76, then the hardness will be at least 115.15 proper Brinell hardness. Next, if we have the ball diameter equal to 10 millimeter, so what will happen? Here we can apply loads 3000 kg or 1000 kg. And if we got the impression of 250 kg, 2.51 millimeter, since I apply 3000 kg, we'll know the hardness is 597 Brinell hardness number. Or if we got the hardness equal to 2.68, and with the applied load of 3000, so it will be have 530 Brinell hardness number. Similarly, here for application of 385 kg load, the impression is 2.893, 2.11. That is the diameter of the impression, and this is the diameter of the. This is the amount of. This is the amount of hardness which we are having from our test piece. Say another 3000 cases, we are getting hardness 23 only when this millimeter becomes 3.16 millimeter size as well as side. Next. So another 10 millimeter ball. You are using here, say 3000 kg of indented load. and we are getting say ball weight, ball impression of size 3.58 millimeter. So we'll ascertain that that is the Brinell hardness number is equal to 288. Or if we apply 1000 load, the real number again reduces to 9.5. And the 210 millimeter ball, we are say having using 1000 kg weight and getting an impression 4.4 here. So the hardness will be 62.4. We are taking 146 kg of equivalent work can produce 4.95 result. So again, the same 10 millimeter ball, which is shown that is at the maximum use, we are using 3000 kg and getting the impression of say 5.330. So we have hardness less than 126 Brinell hardness. So the deeper the impression, our hardness is reducing. Say for the same load, we are having more impression as 5.30, and we are getting less hardness from our workpiece. If this impression is less, hardness should be comparatively better. Say for 10 millimeter ball of 3000 kg, 10 millimeter ball 3000 kg. I will apply indented load. The ball diameter is 10 millimeter. So what we got 4.37 millimeter diameter of the impression, 350, 250, 350, 250. And if the answer impression is 4.5, by applying 3000 kg, its hardness will be 187. This is the method of calculating the Brinell hardness test. Let us go through a few videos to understand the process in more clearly. Next will be
This is our Brinell hardness testing machine. It is kept over a table, and over the table along with the machine we have our microscope, test workpieces, and the indenter itself kept side by side. In the table, in the machine, we have a load lifting platform like here, a indenter holding device, and a load actuating rod which will load the load when rotated clockwise and unload the load when rotated anti-clockwise. The load is kept or fixed on the platform or hanger like this, over which a load of up to 3000 equivalent weight, 3000 kgf or 3 metric ton can be loaded. And we have the loads as kept on the floor. We have 6 different weights. Of each of them are equivalent. 4 of them are equivalent to 5 kgf weight. and two of them are equivalent to 50 kg of weight. This can be loaded over this load actuating over this hanger, one at a time, one all at a time according to the requirement of our job. This machine is defined and known as Brinell hardness testing machine. This is our Brinell hardness testing machine. It is kept over a table, and over the table along with the machine we have our microscope, test workpieces and the indenter itself kept side by side. In the table, in the machine, we have a load lifting platform like here, a indenter holding device and a load actuating rod which will load the load when rotated clockwise and unload the load when rotated anti-clockwise. The load is kept or fixed on the platform or hanger like this, over which a load of up to 3000 equivalent weight, 3000 kgA for 3 metric ton can be loaded. And we have the loads as kept on the floor. We have 6 different weights. Of each of them are equivalent, 4 of them are equivalent to 5 kg of weight and 2 of them are equivalent to 50 kg of weight. This can be loaded over this load actuating over this hanger, one at a time, one all at a time according to the requirement of our job. This machine is defined and known as Brinell hardness testing machine. Here an aluminium workpiece is kept above the loading and unloading platform, and it is and a 10 millimeter indenter is fixed over the indenter fixing device. The aluminium the table is raised by rotating the handles clockwise and anti-clockwise to lift it so that the workpiece engaged in the indenter itself. Next, load actuating rod is kept on the left side, and you have to move it clockwise to engage the load itself. And on the hanger, a 250 kg weight is fixed, as the hanger itself can produce 500 kg equivalent weight. Totally, we can engage 750 kg of equivalent weight, which is good for making the impression of the aluminum itself. Now I am creating the impression by moving the load actuating rod clockwise in the position so that it engages the indenter to the workpiece, and kept it as it is for more or less 5 to 10 seconds, and then actually unloading the indenter and total lifting device is brought downwards here so that the impression created can be visible over it, which is here. This diameter of this impression can be measured by means of the microscope itself, which with an accuracy of 0.01 plus minus 0.01 millimeter. Here an aluminium workpiece is kept above the loading and unloading platform, and it is a 10 millimeter indenter is fixed over the indenter fixing device. The aluminium the table is raised by rotating the handles clockwise and anti-clockwise to lift it so that the workpiece engaged in the indenter itself. Next, load actuating rod is kept on the left side, and you have to move it clockwise to engage the load itself. And on the hanger, a 250 kg weight is fixed, as the hanger itself can produce 500 kg equivalent weight. Totally, we can engage 750 kg of equivalent weight, which is good for making the impression of the aluminum itself. Now I am creating the impression by moving the load actuating rod clockwise in the position so that it engages the indenter to the workpiece, and kept it as it is for more or less 5 to 10 seconds, and then actually unloading the indenter and total lifting device is brought downwards here so that the impression created can be visible over it, which is here. This diameter of this impression can be measured by means of the microscope itself, which with an accuracy of 0.01 plus minus 0.01 millimeter.
Let us share a few videos downloaded from YouTube. It will be better.
Today I am conducting the experiment of Brinell hardness number. This is the experiment. Now this is the tableau column. We have to find out the Brinell hardness number for ferrous material 187.5, major diameter 250 mm, minor diameter for non-ferrous material. These are the major diameter for the ferrous and non-ferrous. The indenter will be 2.5 mm, 5 mm. This is the tableau column. This is the ferrous material, mild steel, cast iron. The indenter used is 2.5 mm diameter indenter. This is the 2.5 mm diameter indenter we are going to use. For non-ferrous material, this is the non-ferrous material. We are using the 5 mm indenter diameter. Now, this is the platform. For ferrous material, we have to fix 187.5 kg and fix the indenter here with the help of Allen key. With the help of Allen key, you have to fix here. Now indenter is fixed here. Cast iron is placed over the platform. With the help of elevating screw, rotate clockwise direction such that the specimen touches to the indenter. As it touches to the indenter, we have to apply the minor load 3 kg. A small needle moves anti-clockwise direction 3 kg and larger needle moves 0. Small 3 kg, larger will be 0. Now apply the load. The larger needle will moving in anti-clockwise direction. Okay, as the larger needle stops, you have to wait for 1 minute in case of Brinell hardness number. In case of Rockwell hardness number, you have to wait for 30 seconds. Wait for 1 minute. Then unload it. Unloading should be slowly. You have to carry it out. Go for next trial. Because here we are using microscope in order to find out the indented diameter. Go for next position. After getting the indentation with the help of a chalk piece, you have to mark over the indenter. This is the part. This is the indenter. This is the indentation. This is the indentation I have done it. Again I will do for second indentation. I will place over the platform. Apply 3 kg minor load. Load is applied. This is the second trial. We are performing it. As the larger needle stops, wait for 1 minute. Wait for 1 minute. Next, unload it. Move the anti-clockwise rotation. Remove the specimen from the platform. Go for marking here. Go for other color chalk piece in order to get. This is the indenter here. There are 2 indenters, this and this. Next I will go for third indentation. Place over the platform. Rotate it. 3 kg minor load is applied. Load is applied here. As the larger node is moving in anti-clockwise direction, I am performing in a faster way, but in exam you have to wait for 1 minute so that the material enter into the plastic region. Now wait for 1 minute. Now unload it. Unload it. Anti-clockwise rotation. Now mark the specimen with the help of other chalk piece. The 3 indentations. This. One more is here, one more is here, one more is here. Now, with the help of this microscope, place over the specimen. That part here. Now there is the marking over here. Count the line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means the first indentation is 10. 10 is nothing but 1.0 you have to write. The second reading is, again count the line, it is 11. 11 means you have to write 1.1. I will go for third reading. It is 1.1. 11 is nothing but you have to consider 1.1. Consider 1.1. In this way you have to perform the test. I have considered the ferrous cast error. From the microscope, this is the microscope you have to find out. And after getting this value, go for mean and substitute in the formula. In case of ferrous material, please change the value. Load 250 and indenter will be 5 mm and it has to be fixed here, and you have to repeat the procedure. Same procedure you have to repeat after taking the readings over that of the specimen. This is the specimen, aluminum and